Hi everyone, welcome to math class today on Thursday, April 16th. Got a nice, quick, easy entrance task for you today. You're just going to name the three-dimensional shape and then state the number of faces, edges, and vertices. This is from earlier in the unit, a little quick review because on the practice quiz that I'm giving you, normally if we were in regular school, this would be your regular quiz we'd have today. The first couple of questions are talking about naming three-dimensional shapes like we did in the earlier part of the unit. I think it was around page 4 or 5, something like that. And then also counting the number of faces, edges, and vertices that we did on the following pages. So take a minute to see if you can see the difference between these shapes. I picked these ones because they're two of the trickier ones. And then hopefully you can see the number of faces, edges, and vertices on these. Alright, hopefully you paused it and you're back. So one of these is a pyramid. Hopefully you said that it was number 1. This one's a pyramid. You could call it a square pyramid. It appears to be a square. You can't tell for sure. You can also call it a rectangular pyramid. A pyramid has just one base to it. That would be the rectangle, so they call it that. And on the opposite of the base, there's one common vertex that all the edges leaving the base meet at that one common point. All right, so that's a pyramid. This one is not a pyramid. This one has two bases. The two triangles on the ends are your two congruent and parallel bases. So this would be called a triangular, named by the shape of the base, triangular prism. So in general, pyramids, one base with one single vertex across from it. Prisms have two bases that are parallel and congruent. Congruent meaning same shape and size. Alright, let's talk about the faces, edges, and vertices. It turns out they each have 5 faces. This pyramid has a rectangle on the bottom and then 1, 2, 3, 4 triangles for a total of 5 surfaces or 5 faces. This one has 5 faces as well. This one has the 2 triangles and then 3 rectangles connecting each side of the triangle to each other. So that would be a total of 5 faces. The number of edges here would be, there's 4 on the bottom and 4 going up to the top. So 4 and 4 is 8 edges. Here we have 3 edges on the front triangle, 3 edges on the back triangle, so that's 6, and then 3 edges connecting each point of the triangle, so that's a total of 9 edges. And vertices are the number of points where 3 or more edges come together. So you can see I got 1, 2, 3, 4 points on the bottom and then a point at the top, so that's a total of 5 points. Called a vertex, or the plural is vertices. So that was 5 vertices here, and then on this one we have 6. 1, 2, 3, 4, 5, 6. That's just a quick review of naming three-dimensional shapes. So we have not done surface area of pyramids, and we won't. We will do volume of pyramids after. We'll start volume either, maybe I might introduce it tomorrow, or maybe on Monday I might start volume. We will do volume of pyramids and prisms and cylinders and also cones. We haven't talked a lot about cones yet. The only thing you're going to do surface area for is the prisms. So we've done triangular and rectangular prisms, and we'll also do the surface area of cylinders. And you did some of those problems yesterday. So let's take a look at your problems from page 13. I have the answers kind of done out for you here. So we'll take it a row at a time. So anytime you have a prism, I think the easiest way to find the area is to find the area of all the faces and then add them up. Number 1's a rectangular prism, so each side, each face is going to be a rectangle. So the top, you can see T here is 12 because it would have been 6 by 2. 6 times 2 is 12, so top and bottom are 12. Okay. The left and right are 2 by 12. 2 times 12 is 24, so the left and the right were both 24. And the front and the back were 12 by 6. 12 times 6 is 72. So there's your 72s. I add them all up and I get 216 feet squared. Triangular prism, the three rectangles are just as easy. 5 times 11. The other one's also 5 times 11, and the bottom is 6 by 11. So you just multiplied 5 times 11, 5 times 11, 6 times 11. But for the triangles, it's like a separate mini problem here. To find the triangle, remember the triangle, area of a triangle formula is slightly harder. Instead of just base times height, it's base times height divided by 2. Okay? So when I do the base times height divided by 2, I plug in the base of the triangle 6 and the height of the triangle 4. 6 times 4 is 24. Half of 24 is 12. So the front is 12 and the back triangle is 12. If I add up 12, 12, 55, 55, and 66, turns out to be an even 200 square centimeters, or 200 centimeters squared. Next line here, I had 4 and 5. Here's another triangular prism. The difference is this is a right triangular prism, so when I do this separate problem right here with the star next to it, all right, the base of the triangle is 12, the height of the triangle is 9. So to find the area of this front triangle, it would be 12 times 9 divided by 2, which is 108 divided by 2, which is 54. So the front triangle area is 54. The back triangle that you can't really see, I could kind of sketch in if I wanted to make it see-through. It's like a magic. Kind of makes it see-through there. So you have the front triangle that's 54, the back triangle that the area is 54. Then you have the rectangles. The bottom rectangle, 12 times 6, 72. Left, 9 times 6 is 54, and this diagonal one is 15 times 6, which is 90. Add up all my faces, 324. Okay, this one here, again, I don't need to go over every part of it, but you can see the work over here and pause it if you need more time. Again, this is just like all the other ones we've done where it's a rectangular prism, so it's 6 faces there. You need to add up the area of all 6 faces. And then you had one of the cylinders here finally on number 7. That's the one I suggest that you guys use the formula for. 2 pi r squared plus 2 pi r h. Okay. 7 is my radius, 11 is my height, the distance, the height, a 3-dimensional height, the height between the two bases, between the circles. So I plug in those into the formula, do the calculations. Everything that we'll do for online will be in terms of pi, so we'll just leave pi in there to the very end. Follow the order of operations, so I do the exponents first, and then I do my multiplying, do adding last. And I get my answer of 252 pi inches squared. And then number 8 is another one where I have to find the area of all the rectangles and add them together. Okay? So that was the problems you should have tried yesterday. What I'm going to show you guys and have you try for tonight is that practice quiz. So I'm putting the link to that quiz right on the Google Classroom. It looks like this. First two you're going to name the shape, and for this one you're also going to tell me the number of faces, edges, and vertices that this thing has. And I have a word bank for naming those. I introduced this when the very first day of surface area of Prism, this 2 times the area of the base plus the perimeter of the base times the 3-dimensional height, the height between the bases. I don't recommend using this formula. I would not use it. For prisms, I would simply find the area of all the faces and add them up like we've been doing the whole time. For the surface area of a cylinder, however, I would use this formula. So you have a surface area of a triangular prism down here. Then on the other page, you have a rectangular prism and 2 different cylinders to do. I changed the directions here so it says in terms of pi, again, because you don't have a calculator. Be careful on that last one too. They didn't give you the radius, they gave you the diameter on the bottom. So be careful on that. So I'll go over these answers tomorrow. Again, please try all these, and hopefully you do pretty well on it. We've been practicing it for a few days now. Alright, have a great day. Good luck on the ungraded quiz here for you, just kind of to see how you're doing. And I will talk with you guys tomorrow. Alright, have a good day. Bye.